I'm K. Sai Namrata Chaudhary from ITB section studying in second year. My register number is 22BQ1A1283. Today I would like to say about permutation function. First of all, what is function? A function is a relation and it is a part of A cross B as relation is defined from A to B. Here a relation is said to be a function when each element of A has an image in B. Suppose if you take 1, 2 and here AB and the mapping is like this. Here the elements of A, that is 1, 2 has images in B, that is A, B. If we observe this type of relation, then it is said to be function. And now I would like to say about permutation function. What is permutation function? A function is said to be permutation if it satisfies bijective. And coming to bijective, it should satisfy 1-1 function and all-2 function. 1-1 function means the elements of A has different images in B. This type of relation is said to be 1-1 function. On-2 function refers to range equals to codomain. Then the relation is said to be on-2. If it satisfies both the properties, then it becomes bijective, and then the function is said to be permutation function. And for example, a relation is considered like this: 1, 3, 2, 4, 3, 5, 4, 1, 5, 2. Relation is defined from A to A. So if you write permutation function, then first write below elements here 3, 4, 5, 1, 2. Then we need to take domain, that is 3 below element 5. So we write here 4, 1, 5, 2, 1, 3, 2, 4. This becomes the permutation function for this one. Here, if we consider the types of permutation functions, there are many types, and one of them is identity permutation. If a relation is defined from A to A, then permutation function becomes F equal to if we observe the function like this, then it is said to be identity permutation. Next type, inverse permutation. Here the relation is defined from F, A to B. If function is written for this, that is permutation. Then the inverse permutation function is, and we represent it as F inverse, F of A1, F of A2, F of A3, so on, F of A1, A2, so on, A1. For example, consider the function here, and its permutation be like this, as we discussed above. Then if we take inverse permutation for this, which is represented as F1, then it is as follows: 5, 3, 1, 4, 2, 5, 3, 1, 4, 2, as I discussed above. And coming to next type of permutation, even and odd permutation. Discussing about even and odd permutations, I would like to say about cyclic permutation, as it is based for even and odd permutation. For suppose consider a function like this, then the cyclic function is first step 1 to 4, then 4 to 3, 3 to 2, again 2 to 5, 5 to 1, and this is the cyclic function. Then the permutation function may be 1, 4, 3, 2, 5, 1, or we can follow any order: 4, 3, 2, 5, 1, 4, or from 3 to we can write 3, 2, 5, 1, 4, 3, or we can write for 2, or we can write for 5 again. 1, 4, 3, 2, 5. So here if we count number of permutations 1, 2, 3, 4, 5. As the permutations are odd number for these, so it is known as odd permutation. Suppose if we consider a function with even, suppose if we consider a function and if we write cyclic permutation function, and again we can write transpositions, and these transpositions count becomes even, then it is known as even permutation. Suppose if we take a function and if we write cyclic permutation function and we express it as permutations like this, then if we get even number of transposition counts, then it is known as even permutation. So transposition permutation means suppose a function is considered like this, then we need to express it as cyclic permutation first. Here 1 to 3, then 3 to 5, 5 to 1. As starting and ending are same, it is one cyclic permutation and remaining elements are 2 to 4. So here we get this is one permutation and this is one permutation. This is known as this each permutation is known as transposition. And here we get two permutations. So it is even permutation. And these are all the types of permutation, that is different types like identity permutation, inverse permutation, cyclic permutation, and even an odd permutation, transposition permutation. Thank you all.